Another force that acts on the propeller is the aerodynamic twisting moment. So let's assume we have a propeller here and we have an airflow coming into the propeller and the rotational speed of the propeller giving us a relative airflow such as this, and that angle between there and the chord line of the propeller gives us a positive angle of attack. So if we have a positive angle of attack, we will have positive thrust. Now, the center of pressure on an airfoil is generally forward of the CAG. So we have this thrust vector acting at this distance from the CAG. And that's going to cause the propeller to want to move to a more coarse angle, or a bigger angle, a bigger blade angle, so a more coarse angle. So that will cause the propeller blade to want to increase its blade angle. Okay, so aerodynamic twisting moment tends to move the angle to a more coarse blade angle, but that's only when we have a positive angle of attack. So let's look now. Let's say we increase the velocity. The aircraft goes into a dive, for example. We have the same RPM. So the velocity increases. Our relative airflow is now here, and we can see that the angle of attack between the relative airflow and the chord line is now negative. So if we have a negative angle of attack, we'll get a negative thrust, and that negative thrust will want to bring the propeller blade to a smaller angle or to a more fine angle. So if we have a negative angle of attack, the aerodynamic twisting moment tends to move the blade to a fine blade angle. So just to recap, aerodynamic twisting moment normally wants to increase the blade angle, but if we have a negative angle of attack, it will want to decrease the blade angle and move it towards a more fine position.